Okay, guys, we're going to give this a go. One thing that I'm going to try and do since we're doing the online lessons is I'm going to try and do lessons a little bit shorter and eliminate some of the practice problems so that, because I think you guys will get some practice problems on your assignments that you'll be completing. And then, yeah, we'll just get started. If you guys hear any crashing noises in the background, I have a baby sitting right next to me that I'm trying to entertain and teach you at the same time. So if you hear any crazy noises, that might be it. Okay, so we're going to give this a go. Here we go. We're going to start talking about special segments and circles and how we find the measures of segments that intersect in the interior and the exterior of the circle. Okay, the first theorem that we talk about is called segments of chords theorem, and it says if two chords intersect in a circle, then the products of the lengths of the segments are equal. So basically what that's telling us is if I have this chord AC and it intersects with this chord right here DE, I can find the measures of the smaller segments on each chord just by multiplying. What they're saying is I can take AB times BC and it should be equal to DB times BE. So if I look at an example of that, this one down here, it doesn't matter where I start. I'm just going to multiply the segments. So I'm going to take X. Oops, let me grab a pen quick. Sorry. I'm going to take X times 6, and I'm going to set it equal to 3 times 4. Now, X times 6, I get 6X. 3 times 4 just gives me 12. When I divide by the 6, I'm ultimately going to find that X is equal to 2. That one was a pretty basic example. Okay, this next one here is going to have a little bit more algebra with it. Okay, so like I said before, it really doesn't matter where I get started. If I take this X plus 1, it's going to be on this chord. So I want to multiply it by the segment that's on the same chord. So I'm going to multiply times X plus 8. I'll set it equal to, on the other side, I'm going to take X plus 10 and multiply times X. Okay, since I have two binomials on the left-hand side, I need to multiply or distribute. We think about it like double distribute. So X times X would give me an X squared. And I would take X times 8, which gives me 8X. Now double distribute, meaning now I'm going to distribute this 1 through to both terms. So I get a 1X, so I'm just going to say X plus 8 equal to, on the other side, I'm still distributing. So X times X gives me an X squared plus 10X. Now, when I subtract this X squared, what's going to happen? The X squareds are going to cancel out. Okay, I can combine like terms. I have 9X plus 8 equal to a 10X. And my last step here, if I subtract the 9X, I'm going to end up with X equal to 8 for this problem. Then I could plug it in and find the measures of each segment if it asks me to. Okay, the next theorem, it says secant segments theorem. And it's going to sound really wordy. Okay, so it says if two secants intersect in the exterior of the circle, then the product of the measures of one secant and its external secant segment is equal to the product of the measures of the other segment and its external secant segment. Now, instead of writing out that full theorem, what I would just write down is what you're going to do is you're going to take the whole segment or the whole secant times the exterior. Okay, so what that means is I'm going to take the full length of AC and then just multiply by AB, set it equal to AE times AD. This is going to be a shortcut for writing it out so you don't have to write out that full theorem. So let's look at how we would apply that. What I have on this slide is it says be careful, make sure you use the correct segments, okay? So we're going to start with the whole secant. So if I start with this bottom one, I'm going to get the whole piece is going to be 10 plus 6, which I would say is 16. And then I multiply times the exterior segment, and the exterior is just 6. On the other side, what would you use for this whole segment? I wouldn't call it 8x because to find that full length, I don't multiply the pieces. It's actually going to be x plus 8 or 8 plus x. And then I want to multiply times the exterior, which is just going to be 8. Okay, so when I take 16 times 6, I end up with 96 equal to 8 times x gives me an 8x. 8 times 8 gives me 64. Okay, if I take 96 and subtract that 64, I'm left with 32 equal to 8x. Dividing by 8, I'm going to find my final answer to be 4. All right. The last theorem for today, it says if a tangent and a secant intersect, and the exterior of a circle, then the square of the measures of the tangent is equal to the product of the measures of the secant and its external secant segment. Okay, so basically what they're saying here is this line JM is a secant. I'm going to treat it just like I did before. You can kind of ignore what I have right here. Okay, so what we said before is we take the full secant times the exterior, and the exterior right here is JL. I set it equal to this piece right here is our tangent. It touches the circle at one point. So what we're going to do is we're just going to square it. Okay, so just square the tangent. Now, our example that works with this one, okay, I can start with the secant, okay? So the whole secant, once again, I'm going to use x plus 7 for that whole secant. Take it times the exterior piece, which is x. On the other side, I have a tangent, so here I'm going to say is equal to 8 squared, okay? If I distribute this x, I end up with x squared plus 7x equal to 64. Now, I want to subtract 64 over to the other side because it looks like since we have those three terms, we're going to be factoring that trinomial. So once again, the way that I have been telling you guys to read this is I take 64, I just go read it backwards. So 64, factors of 64 that subtract to give me 7x. Factors of 64 that subtract to give me 7. So if I write out my factors of 64, I get like 1 times 64. 2 times 32, 3 doesn't go in there, 4 times 16, 5 doesn't go in, 6 doesn't go in, 7 doesn't go in, I have 8 times 8, and I say, okay, factors of 64 that subtract to give me 7. None of these subtract to give me 7. So what do I do? Something that you guys learned back in algebra. It is called the quadratic formula. Get excited. Here we go. You guys, some of you know a song which is like x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, that was pretty awful singing from Olson, but you get it, okay? Students' next question is usually, okay, well, what am I using for a, b, and c? The a term is whatever the coefficient is in front of the x squared. Now, this is really just going to be 1 for this one. The b term is what's in front of the x, and the c term is actually that constant that's at the end. It's the negative 64. That negative goes with it. Okay, so from here, I'm just going to plug it into that formula. So x is equal to negative b. So I say negative 7 plus or minus the square root b squared, so I just write it as 7 squared, minus 4 times a was 1, times c. What was our c value? Negative 64. Now I say this whole thing goes over 2 times a, and we said a was 1. And from here, we just continue to break it down. Okay, so I'm going to have, negative 7 plus or minus the square root. Here I would get the square root of 49 minus 4 times 1 would give me negative 4, but a negative 4 times a negative 64 gives me 256, a positive 256, okay? So from there, if I add 49 to 256, I get the square root of 305. All over 2 times 1 gives me 2, okay? So from here, I can just plug it into my calculator. Now, if you do not have a calculator at home, use Desmos. That's the one I would do, desmos.com. I think you guys have been using it. Okay, so what I would plug in is negative 7 plus the square root of 305 divided by 2. And I end up with 5.23. Okay, now if I do the other one and I say negative 7 minus the square root of 305 and divide by 2, I end up with a negative 12.23. So once again, we have a positive value and a negative value for our solutions. It is possible for both to work, but if I look at my diagram right here, I have x as a segment. Can I have negative 12.23 as my length if it's negative? No, so I cross it out. I say you can't be a solution. My only answer here is 5.23. And then, of course, they ask us to round to the nearest tenth, so my final answer should really be 5.2. Okay, and that was a really long example, but you are going to use this quadratic formula right here in your assignment today. Okay, so all I have left on here is like a couple extra practice problems. What I would recommend that you do is just pause your screen or pause my video and try and work through them and then come back and check them real quick. I'm going to work through them fairly quick if you're just working along with me though. So this one is the chords, and we just take the segments of the chords. So like x times 9 is equal to 3 times 6. Here I get 9x equal to 18, so I'm going to find that my x value is equal to 2. The next one I have a secant, and how do I work with the secant? I do the full secant, so 20 plus x times the exterior piece, which is 20, and I set it equal to the tangent. I want to square it. Okay, so here I get 20 times 20 gives me 400 plus 20x is equal to, if I go 31 squared, I end up with 961. Now if I subtract that 400, I have 20x is equal to 561. And if I take 561 and divide by 20, comes out to 28.05, and they asked me to round to the nearest tenth, so I'm going to say 28.1. Okay, the last one works with two secants. So once again, we do the whole secant. So I have x plus 10 times the exterior, and I set it equal to the other one. If I did the full secant, I would say 3 plus 5, which gives me 8 times 3. Okay, so here I end up with x squared plus 10x is equal to 24. Now if I subtract the 24, it looks like I get x squared plus 10x minus 24 equal to 0. And from here I need to factor. Okay, so factors of 24 that subtract to give me 10. I'm going to say like 1 times 24, 2 times 12, and there would be my factors of 24 that are going to subtract to 10. So I'm going to say this is an x plus and an x minus because that's a negative at the end. To get a negative number, I take a positive times a negative. Okay, and since this needs to be a positive 10, I'm going to say this is a plus 12 and a minus 2. Okay, now just a reminder, to get our solutions from here, we need to set them equal to 0. Okay, so I'm going to work above. I'm going to say x plus 12 is equal to 0 and x minus 2 is equal to 0. I would get x is equal to a negative 12. Is that going to work here? No go. So that is out. That means my solution has to be x equal to 2. Okay. One last example that I want to try, if my computer will let me. Uh-oh.